Welcome to lesson 62, where we're going to check one-step equations with substitution. While I work through these models, here are the things I want you to look out for that show that I can solve the problem and so you can practice and have the same level of success. First, watch how I determine whether or not the series of expressions are equivalent. How do I check for that? And then how do I justify it using my words? And then again, just like in the last lesson, look to see how I'm applying my principles to really simplify those expressions. And finally, how I use substitution to verify if my expressions are equivalent or not. Simplify the following algebraic expression using your knowledge of commutative and distributive properties. 7 times parentheses x plus 2 minus 2x minus 5. How many equivalent expressions did you write and simplify it? And finally, how can we use substitution to prove your simplified expressions are equivalent to the original? So very similar to the multiple choice we had in lesson 61. Here's our original. And I'm going to use my properties. So my first property I'm going to use is my distributive property. So I have 7x plus 14 minus 2x minus 5. Let's look for those like terms. So here are terms that have an x, and here are my whole numbers. Okay, I'm going to rewrite them so I have my like terms next to each other. And now we can simplify. 7x minus 2x leaves us with 5x, and 14 plus negative 5, or 14 minus 5, it's going to give us 9. Alright, so we have this in simplest terms. So this is one equivalent expression that we can have right here. Do we have anything else that we can do with this? Do they have a greatest common factor? No. And I can just see this one. So I could be creative and I can just write other ways. Let's see. How many equivalent expressions did I use to simplify it? I have this one as my first expression. And I have this one as my second expression. Now I can make up other expressions. So for example, I could do 2x plus 3x plus 9. I could do something like that if I wanted to just create another one, but it definitely would be in simplest terms. Just being creative if I wanted to, but I just wanted to show you the two other equivalent expressions I made just working through this problem with my properties. Alright, now here's the second part. They asked, how can we use substitution to prove that our simplified expression is equivalent to the original? So we're going to make up a term for x. In this case, let's just make x1 and make it nice and easy. And let's start with our original, our OG. 7 times x plus 2 minus 2x minus 5. And if I have an x as a coefficient, notice I'm going to use parentheses. In this case, x is by itself, so I'm just going to leave it there. X plus 2 minus 2. Here, I'm going to put a parentheses around it so I don't make a negative. And here's minus 5. Okay, now I'm going to use my order of operations and work on what's in the parentheses first. So 7 times 3 minus 2 times 1 minus 5. Great. And just so, again, if you wanted to see, that's all I'm doing, my order of operations. There's no exponents here. So let's do our multiplying and dividing. 21 minus 2 minus 5. And now we'll just add or subtract from left to right. 21 minus 2 is 19. 19 minus 5 gives us 14. So the value of our very first expression is 14. Let's look at our second expression and see if that's also true. So 7x minus 2x plus 14 minus 5. And notice that these two are exactly the same. I've just moved terms around, but they're the same terms. So I'm just going to use this one here. And I'm just going to substitute the 1. 7 times 1 minus 2 times 1 plus 14 minus 5. So I have 7 minus 2 plus 14 minus 5. I'm still going left to right. 7 minus 2 is 5. 5 plus 14 minus 5. 5 plus 14 is 19. 19 minus 5 gives us 14. So you can see they're both exactly the same so far. So we're doing good. Let's do one more. Our very last one, our simplest one. So this one's nice and easy. 5x plus 9 So 5 times 1 plus 9. 5 times 1 is 5. 5 plus 9 is 14. So all three of them are equivalent. Here we go. So we did it, Math Marvels. We used substitution to prove that they were all simplified and equivalent to the original expression. Hit pause so you can jot this one down into your notes. Let's look at our second practice problem for today. Write an equivalent expression to the expression 1/4 times 24x plus 8 plus 4x plus 3. So pretty much I have to create expressions that are equivalent to this long expression over here. And so what do we see and notice? Well, off the bat, you can see that we're going to need the distributive property in order to solve this. And you can definitely see that this is not written in simplest form. So here's my plan. One, I'm going to use my distributive property to create an equivalent expression. That's going to be the first one. Then I'm going to combine like terms to create a second equivalent expression. And I'm going to check to make sure the expressions are equivalent by substitution. I'm going to say 1x equals 1 to see if those two are equal to the original expression. And then I'm going to have an additional surprise. I'm going to show you how I can combine like terms and look for a greatest common factor to possibly make a third expression. We're going to call that factorizing. So hit pause so you can see this plan and watch how I put it into action. There are a lot of steps here, so feel free to hit pause as I'm going through different parts to try and think, what is she doing and why does this make sense? And if you're still stuck, ask questions or leave questions in the comments of videos. I love answering them. All right, let's start by using our properties. I'm going to start with our distributive property. I'm writing my original expression. And because I have a fraction in front, I'm going to just put one at the bottom to make these fractions while I distribute. Okay, so 1 times 24, I'm going to give myself more room over here, is just 24. And 4 times 1 is 4. So my first term is 24 over 4x plus 1 times 8 is 8. In case you want to see, I'm just doing 1 times 8, and 4 times 1 is 4. Plus 4x plus 3. I'm going to simplify those fractions just to make it a little easier for myself. So 24 divided by 4 is 6. So 6x plus 2, 8 divided by 4 is 2, plus 4x plus 3. So here we go. We have our first expression. Here's our first one. All right, let's combine the like terms now so we can come up with a second expression. So I'm going to put my like terms together. There we go. Actually, I want to get the little sign in there since that's important. Let's rewrite it. 6x plus 4x plus 2 plus 3. And now 6x plus 4x is 10x. And 2 plus 3 is 5. So here we go. I have our second equivalent expression in simplest term. So 1 was just for properties, 2 was in simplest terms. Now, I'm going to give you a third possible expression that we have not talked about yet, Math Marvels. This is called factoring. So I'm going to put this here on the side. I'm going to show you, and it is a factor. And this means, do you see any common factor from 10x plus 5? Do they have any common factors? And they actually do. I can divide both 10 and 5 by the number 5. So watch what I'm going to do. I'm going to put a 5 outside of parentheses because this is a greatest common factor. Now, Math Marvels, watch this. And this is actually really cool. I know we just did all this stuff for properties, but we're trying to find different equivalent expressions. So here's a third one that would be equivalent. If I did 10 divided by 5, you would get 2x. So it's almost like I'm unpacking this again. And 5 divided by 5 would just be 1. So this is my third expression, 5 parentheses 2x plus 1. So there we go. We have 3 expressions now. So hit pause so you can just jot this down. And now we're going to do a check. We have 3 equivalent expressions. Let me make a little space in the bottom just so that I know I have space to write at the end my answer. Let's do our check. we're gonna substitute when x equals 1. Let's just make it super simple. Sub where x equals 1. All right, so let's start with our very first one. 1/4 times 24. I'm turning my x into a 1, so put it into parentheses. Plus 8, close parentheses, plus 4 times 1 plus 3. All right, so let's do what's inside the parentheses first. And 24 times 1 is just 24. So 24 plus 8 is equal to 32. So I have 1/4 times 32 plus 4 plus 3. Okay, let's do our multiplication next. 1/4 times 32 over 1 will give us 32 over 4, which is the same as 8. Okay, so now I have 8 plus 4 plus 3. This is now just all adding. 8 plus 4 is 12. 12 plus 3 is 15. So we have our very first expression is equal to 15. Let's check the other two. Let's try the 10x plus 5. 10x plus 5. 10x is equal to 1 plus 5. 10 plus 5 equals 15. So boom, we came up with another one. Let's try our parentheses one. 5 times 2x plus 1. 5 times 2 times 1 plus 1. 2 times 1 is just 2. 2 plus 1 is 3. So 5 times 3 equals 15. So far, 3 of our expressions are equal to 15. We only have one more left, Math Marbles. I'm going to try giving us enough space for the last one. We have 6x plus 4x plus 2 plus 3. Okay. 6 times 1 plus 4 times 1 plus 2 plus 3. 6 plus 4 plus 2 plus 3. I'm getting excited. 6 plus 4 is 10. 10 plus 2 plus 3 is 15. All of them are equivalent to 15. So here's my full answer. Write an equivalent expression. I created 3 equivalent expressions. And I'm going to make a list. So I'm going to use this nice little symbol. For space, I'm going to start with the 10x plus 5, comma. And now I'm going to put 6x plus 4x plus 2 plus 3. So notice that these two are the same. I just moved some terms around, but the terms are exactly the same. And 5 parentheses 2x plus 1 are equivalent to, and here's my original, 1 for 24x plus 8 plus 4x plus 3. Mic drop. Period. We did it, Math Marvels. We were able to find 3 equivalent expressions. So big takeaway, because I know we did a lot. 1, we used our properties to create an equivalent expression. So these are the same, the terms are just moved around. So that was the first way. 2, we combined like terms to simplify our expression. That was our second one. And 3, our new one was to find a greatest common factor and put it outside the parentheses and have it another third simplified expression. And we checked all of it using substitution to ensure that 1, 2, 3, all 4 of our expressions had the same value. Hit pause and jot this down in your notes.